Trigger design patterns. Design patterns are used to make our code more efficient and to avoid hitting governor limits. Often, developers can write inefficient code that can cause repeated instantiation of objects. This can result in inefficient, poorly performing code and potentially the breaching of governor limits. This most commonly occurs in triggers, as they can operate against a set of records. We will see some important design pattern strategies in this section. Bulk triggers design patterns. In real business case, it would be possible that we may need to process thousands of records in one go. If our trigger is not designed to handle such situations, then it may fail while processing the records. There are some best practices which we would need to follow while implementing the triggers. All triggers are bulk triggers by default and can process multiple records at a time. We should always plan to process more than one record at a time. Consider a business case wherein we need to process a large number of records and we have written the trigger as given. This is the same examples which we had taken for inserting the invoice records when the customer status changes from inactive to active. You can now see the DML statement has been written in for the loop block, which will work when processing only a few records, but when you're processing some hundreds of records, it will reach the DML statement limit per transaction, which is the governor limit. We will have a detailed look on governor limits in a subsequent section. To avoid this, we have to make the trigger efficient in processing multiple records at a time. This is a great example as we're talking about trigger design patterns. This trigger will only fire one DML statement as it will be operating over a list, and the list has all the records which need to be modified. By this way, we can avoid the DML statement governor limit. This is a very good example with the trigger help class. Why? Because writing the whole code in a trigger is also not a good practice. Hence, you should call the epics class and delegate the processing from trigger to epics class as shown in this example. Trigger helper class is the class which does all the processing for trigger. Let us consider our invoice record creation example again. As we can see in the helper class, all the processing has been delegated to the helper class, and when we need a new functionality, we can simply add the code to the helper class without modifying the original trigger. Single trigger on each Salesforce object. Let's always create a single trigger on each object. Multiple triggers on the same object can cause the conflict and errors if it reaches the governor limits. So you can use the context variable to call the different methods from the helper class as per the requirement. Consider our previous example. Suppose that our create invoice method should be called only when the record is updated and on multiple events. Then we can control the execution as shown in this example.